if a sequence is approaching to A, and also absolute value of q is less than 1, show that the limit of an plus an minus 1 times q plus all the way up to a1 times q to the power of n minus 1 equals a over 1 minus q. So the difficulty about this is that the an is in descending order, while q, the power of q is in ascending order. Right? But intuitively it should make sense, because limit of an is a. Right? Imagine if we had a plus a times q plus all the way up to a times q to the power of q minus the power of n minus 1, subtract a. Right? Then we have a geometric sequence. Right? If n approaches infinity, we have 1 over 1 minus q, and then times a. Right? Intuitively it makes sense. But to properly prove this, first let's say, okay, if q is equal to 0, what's going to happen? Right? Then we have limit of an, just limited. Q is gone, right? Just limit of n. Is it equal to a over 1 minus 0? Yes, equal to a. Right, so that's automatically true. So we will just assume that q absolute value is less than 1 and bigger than 0. Right? So it's from 0 to 1 or negative 1 to 0, excluding 0. So in that case, we say that if, in special case, if a is equal to 0, right, the limit if equal to 0, what's going to happen? Right? Then I say, for any epsilon that's bigger than 0, right, then I can use, then there must exist a capital N, where as long as small n is bigger than capital N, I can always have the limit of an minus 0 can be less than half of 1 minus absolute value of q times epsilon. Right, this is always doable, because that's the definition of the limit of an, as long as limit is 0, right, can be smaller than this. So notice that the whole thing is still positive. Right, then I'm going to say, I'm going to denote capital N naught, capital M to be maximum of a1 absolute value all the way a capital N absolute value, right? Because there's only finitely many of them, right? So maximum of those guys plus 1. And the reason I plus 1 is I want to make sure capital M is positive, strictly positive, non-zero. Right? Of course, in this case, right, I fix epsilon. Right? Once given, we fix it. Of course, capital N is fixed as well. So I say that absolute value of an plus an minus 1 times q plus all the way a1 times q to the power n minus 1 absolute is less than or equal absolute value of an plus absolute value of an minus 1 times q plus all the way up to a1 times q to the power n minus 1 absolute value. Right? Triangle inequality. And so that is equal to absolute an plus all the way up to absolute value of a capital N plus 1 times q to the power of, what's the pattern here, right? Subscript and the power, they add up to n. So it's n minus capital N minus 1. Right, this first part. Second part, plus absolute value of a capital N times q to the power of n minus capital N plus all the way absolute value of a1 times q to the power of n minus 1. Right? So this is less than, like I said, every time. So for those little n that's bigger than the capital N, after this capital N, these terms, right, can be loosened by this amount, right? So just subtract it out. Half of 1 minus absolute value of q times epsilon bracket. What I'm left with is just absolute value of 1 plus absolute value of q. All the way, absolute value of q to the n minus 1. Right. And then I'm going to say a1a, right? So I say maximum of absolute value a1 all the way up to a, n is capital M, right? Of course. Of course, every a1, a2, an replaced with maximum is loosened, right? But if I say maximum plus 1, you can also loosen further. Right, that is m factored out, left with q to the absolute value to the n minus capital N plus absolute value of q to the power of n minus 1. Right. Now, obviously this part is a geometric sequence, so is this part. So that would be equal to half of 1 minus the absolute value of q times, first term is 1, right? 1 minus q absolute value and 1 minus q absolute value to the power of n minus capital N plus n times 1 minus q absolute value. First term is this q absolute value to n minus n, 1 minus q absolute value to the power of n to the capital N, like finitely many of them. And so that the fact that q absolute value is positive, right? So is this term. So if I don't subtract it, it can be loosened. Right? Half of 1 minus q absolute value times just 1 over 1 minus q absolute value. I think I forgot an epsilon somewhere here, right? Because times epsilon. And so that this part can be cancelled out. Half epsilon. So I can just get rid of this term, right? Make it a little bit bigger. Capital M times just q absolute value, n minus capital N times 1 over 1 minus q absolute value. And so that all I need to do is to make sure this part can be small enough when n is big enough. So this part, n times q absolute value to the n minus n over 1 minus q absolute value, right? So can this be small enough? Right? I say this this is m times q absolute value to the little n. I put the negative power down to the bottom, right? 1 minus q absolute value times q absolute value to the capital N, right? This is of course true. So if I let this part, m times the bottom becomes m naught, and in which case, because this is already strictly positive, right? So strictly positive, of course, q is strictly, it's not 1, right? So this is non-zero, strictly positive, strictly positive. M naught times q to the absolute value to the power of n, right? So if I let this be smaller than half of epsilon, right? Can I show that as long as n is big enough, this is true, right? So in other words, can I show that when n is big enough, absolute value of q to the power of n can be smaller than epsilon over 2 times m naught, right? In other words, if we apply logarithm on both sides, logarithm is increasing function, of course, this positive, increasing function, still maintain the direction. Log, take down the power, n times log of q absolute less than log of epsilon over 2 m naught, right? When is this true? So q absolute value is less than 1, bigger than 0. Of course, log of q absolute value must be negative. So change the direction, bigger than log of epsilon over 2 m naught over log q absolute value, right? So when n is bigger than capital N naught meaning the maximum of this capital N and the floor of log of epsilon over 2 times m naught over log absolute value of q. Right? So remember, epsilon is any given positive number. Once given, we fix it. Right? Then we found a capital N that's dependent on this fixed epsilon. Right? Then we found capital M, which is dependent on the capital N. Of course, it's strictly positive. Right? And so, as long as little n is bigger than this capital N, and also bigger than this, right? So this can be really smaller than half epsilon, right? This really can be smaller than half epsilon. So half epsilon plus half epsilon, right? So meaning the desired expression minus 0 absolute value can really be small enough, smaller than epsilon, as long as n is big enough. Right? Exactly the definition. So if a was 0, right? So we've proven this limit is equal to 0. 0 over 1 minus, the same thing. So the statement is true when limit of an is equal to 0. Right, this is true. Right, so 0 over something, still 0, I've just proven. So now if a is non-zero, then I say an minus a. Right, let's denote it as bn. Approaching 0. Right, because an approaching an minus a approaching 0, of course. So that means bn, I can apply the special case. Right, bn approaching 0, then of course, which means bn plus bn minus 1 times q plus all the way b1 times q to the power n minus 1, tending toward 0. But that can be written as an minus a plus an minus 1 minus a times q all the way. a1 minus a times q to n minus 1. Right? But that can be written as an plus an minus 1 times q plus a1 times q to the n minus 1. Right? I'm going to just expand everything out. Right? an minus 1 times q times q times q. But then I'm going to group these ones, right? Minus a times q minus a times, so minus bracket a plus aq a times q to the n minus 1. Right? Two parts. And this part I'm going to work out, right? This part, knowing that together they approach 0, keep in mind. But this is a geometric sequence, right? Factor out a 1 minus common ratio. First term is 1. Right? Times 1 minus common ratio to the power of n. Right? As n approaches infinity, q, remember q absolute value is less than 1. So this will just disappear, right? Everything will approach, this whole thing approach a times 1 over 1 minus q, right? But knowing that whole thing is approaching 0, right? This minus that approaching 0, which means this move to the other side. So this will approach this, right? Minus this to the other side, approach this. A over. Indeed,